How are you all doing? So we are all yearly here, so we'll be starting in another 5 minutes. Without wasting any more time, let's get started with the presentation. So today we'll be talking about tooling that I had built a couple of weeks back, and it's about Bloodhound and things like that. When like preserving the attack paths without leading disclosure of any identity information, things about that. So before going to that, quickly about me, the people who don't know about me, I'm Abhisek. I work as a security consultant at NetSpy, and I'm the founder of the Abhishek Cast, which is a podcast where we bring in people who are into cybersecurity, like CEOs, CISOs, and security researchers who talk about cybersecurity segments, which is not really talked more about. So we have around 10 episodes. If you're interested, go ahead and check it out. And I've been also talking at different communities such as Null, Besides, and few more communities as well. So that is little bit about me. Quickly going into the presentation and before getting into the important part, just wanted to cover about Altered Security. So Altered Security is a cyber security company. They provide cyber security courses, not just for the slide, but then I have also taken up two of Altered Security courses. One is CRTE and another one is ARTP. Both ones are really good, which was into on-prem AD and also the Azure side of Active Directory, and both were awesome. So if anyone is interested, please go ahead and take it up. And this is about Hacker Summer. So we are in one of the session of Hacker Summer 2026, but then this is run for a month-long event by Altered Security from different various topics about cybersecurity. So if you are interested, go register for that. And finally, I am able to see the chat section, but then if you are not able to like type in, or if you wanted to like talk about something on after the session as well, you can always reach me on Discord, or else if you have any question about the session, just try to post it on the Discord server. So I'm currently having my mobile phone nearby so that I can see the chats quickly so that I can answer your questions. And so let's get started. Talking about internal network, Active Directory, and Bloodhound. So first, let's cover about internal network. Not sure how many of the people who are very relevant to these topics, but then a quick introduction about internal network. If you are even if you are not aware, you have been using that. So a very quick answer about that is, say if you are connected to an Wi-Fi network, it is in your home. You are again inside an internal network. So this typically works in a similar way. It can be your house or a company or a cafe or whatever it is. Every places where there is some network device and you connect and you access something over there. So there is an internet network around that. So typically, big enterprises and companies have a larger infrastructure in terms of like users logging in, accessing different files, communicating with each other, sending mails, and things like that. So typically taking about a bigger company in mind, and if we talk about Active Directory is actually an product from Microsoft. So they actually implement a way to integrate, say, if there is like 100 different Windows systems in play, we can all connect all the 100 system to one particular piece called domain controller, and the domain controller will be the master node which can like command other PCs. Say, for example, if you had to change wallpaper or push any updates on those system, Active Directory is going to help you do all that. So it implements a lot of different ways for administration, and it's been widely used by every other enterprises. Not like 99% low. So whenever we do pen tests on internal networks, every other time, so 99% of them do have Active Directory, and it's been a very core attack vector when it comes to internal network part. So when we talk about Active Directory, Bloodhound plays a very important role in Active Directory enumeration part. So Bloodhound is a tool which was built by SpectreOps. So this is going to be a tool which helps in sorting out a lot of headache. So basically, when we see a enterprise or a bigger company, there is going to be hundreds of computers, hundreds of files that's going to be there, and thousands of users will be there. So all this system to manage and stuff like that, Active Directory is in place. But then, as a pen tester or even as a blue teamer, Bloodhound is being used as an enumeration tool. So Bloodhound is works like it is going to we can assume that as a script. which is going to run and going to collect all the information that is relevant to the Active Directory that is in play. So to understand a little bit more about Active Directory, so Active Directory can be accessed in two ways, which is unauthenticated and authenticated place. So there, if there is an scenario where you were able to managing, like you are able to access a particular user's credential, say if there was one of a user in a environment who had weak password and you were able to find that out, so you have a foothold on the network. So by default, by the working itself, Active Directory and low privileged user is allowed to query all the nodes. So what does that mean? So if I have a foothold that is a very low privileged user that is present inside Active Directory and I'm able to authenticate, I'll be able to enumerate all the system that is in play, all the users that is present, organization units, and there are different set of objects that's in play. To understand higher level about Active Directory, just assume that as a class and object scenario. So Active Directory, there is going to be a domain, which is going to be the class, and each domain is going to be the instance of that. So we'll be not going too much about Active Directory in this session because we're going to talk about the tooling that is built. So that is an higher level thing. So all Active Directory all has all kinds of different object that is required for administration. And Bloodhound is going to help us gather the information. So once we get to know about how to use Bloodhound, there are a lot of different tutorials, different blogs out there. If you're very interested, if you don't know about that, go and read about that, see about that, and it's a very useful and an interesting tool. So once we do that, once we have an Bloodhound export, so what we are going to see is we will be having a set of JSON files. So JSON files is going to have all the objects that is in play. So there will be like usually there is going to be around 6 to 7 JSON files which is going to be generated. So the each JSON file, for example, there is an user based JSON file that will be there, which will have all the users that is present inside the Active Directory network. For example, the name, the email address, and all the attribute information. So again, the same class object in play, class and object concept here. So each object will have their own attributes. So user object will have its own attributes. So it will be all populated with their set of information. Same applies to a computer. Computer will have its own name and their set of attributes, and similarly to groups and different set of functionalities out there. Once all these objects are enumerated, there is another concept called relationship. So basically, the relationship is about, say, for example, if you are part of an IT team, you'll be part of a group called IT, for example. And similarly, if you are part of an like director or a higher level representative of a company, you might be part of a different set of group which is higher privilege, like domain admins, which will have more administrative access towards all the systems that is in play. So basically, Bloodhound is going to get you an higher level understanding about how the Bloodhound network looks like. It is a graph representation. Once you have all the data in play, you'll be able to load it into the UI that is present, and then you're going to play around that. So simple and easy. So that is all about Bloodhound. So typically, when you are playing with in a pen test where you are going to do a pen test for an internal environment, you encounter an Active Directory domain, and you want to like uh, see about how Active Directory is, if there is any misconfiguration, stuff like that in place so that you can use it for privilege escalation. So to do that, it can all be done manually. You can check into the web interface, go into each objects and see what that is configured of. You can see if that is overly permissive. So what do I mean by overly permissive? Say a domain user who is supposed to be a very low privileged user who should not have any uh, administrative access by default. That is not like if there is no internet use case, there won't be any privileges like that. But if it is present, so you can directly see what are the misconfiguration, what are the outbound inbound links that you have for your object, and see what you can do. All this can be done manually, but what happens if you do manually? So the enterprises environments in usually in a pen test are very big, so very big MNCs, different companies like that. You'd be pen testing in that way, and you'll be seeing 10,000, 50,000 users in play, and manually going through each object. So it's not like that you can write something called cipher queries, which is supported by Bloodhound. But then even having those querying methodology, doing all that manually takes some time. So it is not like it's not doable. It's doable, but it takes time. So the whole point of the problem statement which I came into is, why not let's try to integrate LLMs into this part. So this is where the spark about HoundMasker came up. So the whole part is around talking about like giving this data access to LLM and see if we can do analysis to that. Okay, so AI is great at reasonings. Why not just copy paste the data, whatever we have? So the thing is, all the publicly available instances of LLMs are going to use the data that has been fed in for purposes. So every LLM differ in different ways, but then in general, it can be expected that they can be using the data that we are trying to feed in. It's going to be the model that is in place going to learn about that. So we think about giving an very sensitive information because it's going to have an company's infrastructure like users, computers, how the like privileges are configured. So it's very sensitive, right? So giving it to an LLM is like, no, we should not do that. So stuff like that. And there is a lot of stuff that might be stopping you on doing that. So why not fix that? So not like fixing, but then what is the workaround to that? So what if we actually try to drop the identity? So this is about the core part of the tool that we are going to talk about. So what this tooling is going to do is it's going to find out what are the things that is going to personally identify someone or some object. Like it, say if something is leaked, uh, if there is a data that is going to, for example, if the company name is called example, and if there is some data like called abc.example.com, we are obviously able to map that it is related to example.com, right? So we wanted to drop that down. So what the initial thing that has been thought was to find out whatever is identifiable on the data and try to mask that. So that's the core idea about that. So why not let's just find and replace. Say we have domain names, we are just going to find wherever the domain name is. So basically most of the companies have their company name as the domain name. So why not find the domain name, just find and replace and go ahead and upload? No, it's not like that. So the thing about that is, so there are different users, there are different attributes, there are different relationship in place, and also Bloodhound brings in a new concept called tier zero assets. So tier zero assets are basically like a very privileged assets, very privileged systems, groups that is all in play, that is all been mapped by a specific rule set that Spectrof has dropped in a GitHub repository. I've linked it over here, but then they do map that on Bloodhound UI, which you'll be seeing. Say if you are seeing an object and if you see a diamond symbol on top of that, it means that it's a tier zero asset. So all these relationship and things and attributes are in place. So it can't be a straightforward find and replace case in this matter. So so this is about the GitHub repository which I was talking about, the tier zero table. If you are interested, take a look at that. So coming into the tooling part. So the HoundMasker solves the find and replace part. So it is going to help you mask what is needed to be masked and what needs to be like preserved to make the graph look alike after the process of masking. So HoundMasker is going to take in all the users, group names, computer objects, organization units, and couple of more is also there. I've listed it down all on the GitHub repository, but then all the you, for example, if you take the users, it's going to mask all the usernames that is present inside that. Say if there is like three users, it's gonna list like a random 8-digit alpha numerical set of name underscore and user one, user two, user three. So it's not straightforward identifiable. So it's gonna mask out all those names that is present inside that. So there is something called SID. So it's a security identifier. It is like common for a domain, and every other user, every other object is going to have that security identifier, which will end with an like an RID, which is like a 3-digit number or a 4-digit number that you can see. So a lot of those informations are in there. and say even SIDs are going to be common towards the domain. So SID, which is mapped for the domain, is also going to be swapped. And only the things which needs to be reserved is going to be reserved. So there are, since we talked about a lot of attributes that was in play, and to see a couple of attributes, say for example, description and say logon script, and there are like various different attributes that's like having an ability to have free information, which is like we can't have an regular pattern match on if this is like sensitive or not, should we mask that or not, so things like that. So any field that was found to be like hard to like find out if there is something sensitive or not, like something which can be uploaded to LLMs or not, so which can't be determined, all those fields are empty. And what is untouched? So since we talked about the relationship parts, so there are specific SIDs which needs to be preserved, things like that. So there are some of the SIDs related to, say for example, default administrator that's present on a domain controller machine, so things like that. So there are different set of objects and SID that needs to be preserved. So those things like that are going to be preserved, so it is not going to disclose any straightforward identification name, but then it's going to preserve things like, for example, if there is an user administrator user, obviously the well-known SID is going to end with an RID which is hyphen 500. So the hyphen 500 would be preserved, but the previous set of SID which is going to stay is going to get masked. So that is how this works. There's a very descriptive explanation about what is masked, what is preserved, what is emptied, all on the GitHub repository. You can go ahead and check that. So coming to the tooling part. So now we are going to see a live demonstration on how this tooling works. So first we are going to see how painful it is to run. So I'm going to quickly stop sharing my screen and share the whole screen. Awesome. Can anyone just give me a comment on the chat if you can see my screen? Awesome. Yeah. So I'm right now on the repository. So basically, this is going to be the HoundMasker repository. It's the same folder that you're going to get when you clone from GitHub. So what you have to do is I have all my BloodHound files stored at this particular location. So I'm going to run this command. So it is very simple. So it's a Python tooling. So the Python tooling, the Python script, and then you're going to upload all the JSON files that you have. So once you click that, so once you do that, apologies for the part which it failed. So basically, it had already a file inside that, so it got failed. But then I removed the file, so now it is creating it again. So what it is going to do is it is going to take all the files, so which is cert templates, computers, containers, domains, CAs, GPOs, groups, OUs, uses. It's going to take all of that. It's going to mask and it's going to process that in play. So this is how it masks. It hardly takes like 1 or 2 minutes. It doesn't. It's not going to take too much time because it is not very big data, but it's a decent amount of data that we are seeing. Once everything is done, you'll end up with having an folder name called like modified files with this date, and it will have files like this. So we'll just wait for a moment so that this to complete. Yeah, once it is done, you'll see a summary. You'll see how many domains were there, group like users, the computers, and a very high level highlight about that. You can see that there is a folder created right here. So I have an Bloodhound instance that is running on my local laptop. So I'm going to upload the data that we had generated right now. So it's right now, it's created right now. So once all the data is imported, you can go to file ingestion. So it is ingesting. So it might take a minute or two to complete. So in that, while is there any questions you have? I'll take a pass here until this is done. I can take up any questions if it is there. Awesome. The ingestion is complete. So once the ingestion is complete, you can take a look at this. Let's see the domain trust. So you can see that there are two domains in play and they have same forest bidirectional, like they are on same forest, so they have bidirectional trust. So we have the data, right? So let's get back to the presentation one more time. So typically to answer how painful it is to run, and it's not at all painful to run. It's just you're going to upload the JSON file, so it's going to process it for a while, and once it processes, it's done. So once you have that processed, how does we are going to check if the graph is actually surviving. So what I showed you is actually the mask data which we saw on this browser page. These are mask data which we just uploaded, but then the original data looks like this one. So it is going to be training local and secret training local. So these two were the domain that was in play, but then after masked, it's changed. So you can see it's changed in this way. So you can go inside and see all the data that could have been here is going to be masked. And if you see here, there is the object ID. This is like typically the SID which we were talking about. So the identifier which is right here is also been masked. And you can see the distinguishable name has been masked. And same applies for the users that is present in here. For example, if we take this user, you can see all the data that is in here is it's going to be masked. If you can see the group names, everything is going to stay masked. So this is about how the masking works. So it's very simple. So you just run it. It's going to like run it, get the files, upload it, and it's done. So similarly, I'm just another instance how this looks like. There is an user that is member of like this is a path which we are seeing. So if you try to even enumerate this path, is going to look the same way. So for example, so this path was originally like this, and after masking we'll be still able to see that path that has been here. So it's will be everything will be preserved, everything will be in there. So and it works in this way, then you'll be able to see inside that. So yeah, so the whole part of masking the information is done. So which is what we were more concerned about when we were talking in the initial phases. So the masking is done. So right now let's go and play with LLMs, right? So before going to LLMs, so there is a disclaimer on this tooling. So this tooling is an best effort to try and make out like to find out all the places where it can lick out the identities and find out and mask them all that out. But then there are edge cases which I might not have encountered. So there can be edge cases which can leak data. So always recommend to check the data which was generated, do a grep on all the sensitive information that you have, see if there is any information is actually that is actually in there, so that you don't end up uploading that. And I don't take any responsibility on that matter. So it is like your disclaimer on to check the information which you are trying to upload it to the LLMs. Okay, there's a quick question. Let me take that up. Why are we actually masking it out? Like scenario in this case, you are already collected background data. So why do we mask it out then? So Bloodhound itself is data which is going to be collected from Active Directory environment, and then it's going to have all the data that is going to be preserved, however the organization looks like, and that is what the files that we have got. What we did on the tooling is we gave the generated files from Bloodhound to this tooling, which masked the data, and then we were able to upload it to Bloodhound so that Bloodhound can be used for visualization, because just having the JSON files uh, wouldn't be enough to do analysis, because you can't just do analysis by seeing the files, right? So does that answer your question? Sam? So masking it out. Okay, so for example, let's talk about this one. So you can see that this is an bloodhound data that was present, and you can see there is an user right here, and there are a couple of groups right here, and you can see there is a path which leads to an administrator user. So all this is very specific to which user you have to target. Say, for example, if I had to have this account, I can target this user. Say for this Leah Albert user, what I would do is once I have this information, I would go to LinkedIn and find out if this person has an email address and fish that user, get the password, and see if I can land football. This is obviously a very complex chain, but then this is all that matters. So it is about the identity that is going out. So once you have that data, it is going to leak out a lot of information. But then if you see this mass data, you are not going to know about which account is actually this related about. You have no clue about which one is actually relevant about. So you can't find which user actually has that privilege. Hope you are able to get why we are masking here. Awesome. So without delaying, I'm going to move forward. We have very less time. So I will take any more questions towards the end of the session. So let's bring the data to LLMs. So for the LLM part, so it's going to be up to you. I'm going to demonstrate this with Cloud MCP. So basically, Bloodhound guys, that is Spectrops, already had an MCP built for Bloodhound, so I used the same MCP that was in play, and it is very easy to integrate. You have to do a couple of things to make that accessible. So that's like, so I'll give you a quick hack. If you don't know how to integrate LLMs, you just have to ask the same LLM how to integrate the MCPs that has been in there. So that's typically about that. It's a very easy process, so you can figure it out in your own. So once we have all that set up, so I'm gonna show you my Claude data. So it's gonna be like this, and if you check right here, you can see there is Bloodhound MCP already connected towards the data that we had. So basically what this MCP does is there's a server that is running in behind. So it is going to allow this desktop cloud application to talk with the Bloodhound that we saw just now. So let's quickly ask the basic question. Using Bloodhound MCP, what are the domain present on the present? Let's ask this. So this is going to use the MCP that is in play and going to get you the data that you want. So it took out two domains that was in there. We can see this domain and this domain, and we can like quickly cross verify if that was the information. Can see this domain and this domain is there. So that is the same information that we got from here. So, yeah, it's a very simple query. So it's not like a very big magic trick that I did. So it's a very simple query. We saw it here as well. So the things where which it's very helpful is like we could ask Claude about like what are the say if I have domain user already with me, what are the easiest parts to domain admin on this lab? So it's going to use the MCP. It's going to do a lot of cyber queries and things like that. So typically, this particular chat is not trying to run Bloodhound based queries. But then, if you have a chat already or the context window already trained up for cipher queries, it's going to do it very like fast, and it's going to have a lot of contextual information that it can take a look. Like right now it doesn't have more context about that, so it can have a lot of idea before actually doing it. Mhm. At the time this runs, I'll just see the information, the question that's in there. Can you please share the link to HoundMasker script? Yeah, it's in GitHub. I'm gonna show you the GitHub repository towards the end. I'm more interested in how demasking the data will happen using the mapping in case if Claude gives us a command and it includes force, etc. in a single line. Right, I have something for that. It's gonna come up after this part, so I'll show you that. The data imported to Bloodhound is just JSON. I think just replacing the attribute like exam name or something, just yeah. So basically the uploaded data is JSON, but then the problem is there are a lot of relationships that you have to preserve so that it preserves all these relationships what you saw right here. So that's the place where it becomes tricky. So that's where I bring in this tool to solve this small problems that you have and enable the using of AI in this case. So that is about that. So we have got three things, three parts, which is say, let's take the first one. So it is Kerberos to domain admin. So there is a Kerberostable account, which is a domain administrator. So if you have an authenticated user with you, you can Kerberos and get an hash, which you can crack. So basically, you will get an Kerberos ticket, like a service ticket that will have encrypted password of a domain admin. And you can see if it has a weak password. So if you crack it, there's a straightforward win. And there is ASREP roasting. So this is very more interesting about even so Kerber roasting is an authenticated attack. ASREP roasting is not. It can be done um, even without having an domain user in play. So let's just take Kerber roastable user. Let's ask for command for this. Give me commands to uh, for this part. Yeah, so to Kerberoast, we usually use a tool called get user spns.py. It's from Impacket. And for example, it's going to say this. So this is like very gibberish, right? We don't know which user this is. If we had to go to the mapping file and check it out, it's gonna be a hassle, right? So this is where I brought in like an helper tool. So which is like called unmask. So you have to there's a file called unmask right here. Oops, unmask right here. So you have to just run python 3 unmask. You have to uh, put this option and map in the mapping JSON. So once you have that, it is going to get you an interactive mode. There is also a couple of modes which you can explore, but then this is a very like easy mode because you can just have it open and you can just copy paste. So once we have all this data, I'm just gonna try it with all the like commands that's here. So it's like a couple of commands it has given, but then I'm just gonna copy paste it. So we have a lot of information right here. Oops, it's not clear. Let me rerun that. Let's do it step by step. It's not really showing well. So taking this, let's replace that. So once you do that, it's gonna show you the username. It's called DA right here. So we can also try this out. Can see what happens here. So I can see it can, so it had a SPN, so it was able to get back the SPNs to the normal state. So this is where the script helps in, because basically what you are going to see in this, what you're going to see in this mapping files is going to have a lot of, like, lot of information that is trying to map. So each time if you had to like grab it out and see what user it is relevant to and check it out, it's going to be a like hassle to check each and every time and come back and then check. So for those cases, you can just use the interactive mode that is something which I showed you right now, so that you can use that and you can check it out. So this was another example when I was preparing this presentation. So it was asking about an ACL which is to exploit this computer, and then it found out that authenticated users had generic rate on computer 5, and then it had computer 5 had generic rate on computer 116, which was a tier 0 asset, and it was able to give give the commands that needs to be executed, and use the unmasker script. You can just put in here, it converts it, and you can try. But a disclaimer would be right here is, you can't solely rely on just the command which is it is giving. You have to do your due diligence to see if it is actually giving you the right command, because that's something it's up to all the LLMs, or any AI that is in place. You have to play around with that and see if it is actually the correct thing that you're seeing. So basically, this is to answer Jahid's question on demasking the data. So this is how the demasking is going to happen. So any user, for example, say for example, if we had that uh, Leah Albert name, right? So we can give it a try if that can be checked. It's gonna show you what name this belongs to. So you can see this belongs to this name. So it's an interactive place. You can try to talk with like what are GPs data that you got from the mask bloodhound, but then that is something that you talk about. Right. So this is about the masking and demasking part. So there is one more part which I wanted to cover, going to the AI caveat. So after building the tool, so I had posted this on LinkedIn, and I have also wrote a blog post about that and how this works. So whatever I explained on this session is available in a blog post, which is about talks about how this works and the masking parts and things like that. It's all explained over there. So if you had to circle around, you can definitely go and check it out. But then if you find out any issues, you can reach out to me. You can put a PR and stuff like that. But then the AV caveat which I came across is that even the data is masked. Some of the AI people who are working deep into the research part are a bit skeptical about even uploading and masking masked data to LLMs, because it potential risks are still there. But then it's a very big question to answer. I don't have an answer for that. But then that's about the AI caveat that is in the sanitized data. And the limitation about the current version is it only works for the on-prem Active Directory files. It doesn't support the Azure Hound, which is the same tooling, but it is built for mapping out the data and the privileges that you have on Azure part of site, which is not supported yet. But then soon, if I get some time to work on that, I will bring inside that. And where can you find the blog and where can you find the tool? So I hold a domain called abhisek.in. You can go and check it out on the blogs. There will be a blog post, and you can also go to my GitHub profile and check for HoundMasker. So you should be able to get that. If you also have to like check out for the link, you can just go into my LinkedIn account and also check for this. And typically, I also found a relevant tool about this. It's called Anonymous Hound. It's a PowerShell tool. Does relevant masking activity. I haven't checked around that, but then it also masks the bloodhound data. But I haven't checked the comparison of how it masks and how what are the limitations on that and mine. I haven't compared that, but then this is there. It's up to you to check it out. And that is all I had for the session. And I'm here up to take up the questions that you all have. So the space is open for you guys to ask questions. Thank you, Bijayan. Yes, actually, it doesn't support Azure Hound, right? So is there any other final questions? Yeah, so the one which I showed you is actually a local instance. Oh, you're asking about the MCP. So MCP is actually like you have to do a couple of configuration on Claude. You have to download the MCP server that is present on a GitHub repository of Spectrops. Once you get that, you have to do a configuration file, and you should also generate an API key from the Bloodhound instance that you have. You have to like put an configuration. So once that is done, Claude can use that configuration files to access your local Bloodhound instance. Awesome. Thank you so much. So I would like to thank Altered Security for inviting me for the session. Really had a great time. And I'm really also a fanboy of Altered Security because the CRTP, which I recently did, the course of contents were very awesome. So really a fanboy of Nikhil's teaching. So that was amazing. Amazing audience. Thank you so much.